Suspended in the void, our planet is an oasis, wrapped in a fragile, shimmering veil of gas. This is Earth's atmosphere, an invisible ocean just a few hundred kilometers deep. It's the only thing standing between us and the cold, unforgiving vacuum of space. It's what makes life, as we know it, possible. Look at our neighbors. Venus, choked by a runaway greenhouse effect, its surface hot enough to melt lead. Mars, a frozen desert, its atmosphere stripped away, too thin to hold warmth or shield from radiation. Our world exists in a delicate radiative balance, a cosmic tightrope walk that has allowed life to flourish for billions of years. But we are fundamentally altering this balance. We are poisoning our own invisible ocean. Here's the hard truth, a reality often lost in the noise of daily life. Air pollution is one of the greatest environmental risks to human health. It kills more people each year than car crashes, HIV, and malaria combined. The latest global health estimates attribute around 8.1 million premature deaths every year to this silent killer. The economic burden is staggering, measured in trillions of dollars from healthcare costs and lost productivity. And the problem is pervasive. About 99% of us, that's basically everyone on the planet, breathe air that exceeds the World Health Organization's health guidelines. To understand how we got here, we have to go down to the quantum level. Our atmosphere is mostly nitrogen and oxygen. These are simple symmetrical molecules. When infrared radiation, heat, rises from the Earth, these molecules are transparent to it. It passes right through. But other gases like carbon dioxide, methane, and nitrous oxide are asymmetrical. Quantum mechanics dictates that this asymmetry allows them to absorb the energy of an outgoing infrared photon. They vibrate, they get excited, and then they re-radiate that energy, often sending it right back down to the surface. This is the greenhouse effect. It's natural, but we've supercharged it. But it's not just the gases, it's the particles. I'm talking about tiny invaders, particulate matter, specifically PM 2.5. These are microscopic particles, less than 2.5 micrometers in diameter, 30 times smaller than a human hair. They come from burning things, smoke from wildfires, exhaust from traffic, fumes from factories, and even from indoor air when cooking without good ventilation. This is the front line of the battle for our health. When you breathe, your body has defenses, but these particles are too small. They slip past the defenses in your nose and throat, traveling deep into your lungs, lodging in the delicate air sacs called alveoli where oxygen enters your blood. From there, they can cross into your bloodstream, hitching a ride to every organ in your body. They act like tiny Trojan horses, carrying toxic compounds that trigger inflammation and oxidative stress, a kind of biological rust. This systemic inflammation is linked to a terrifying list of diseases: heart attacks, as plaque in our arteries becomes unstable, strokes, as blood vessels in the brain are damaged, asthma, as airways become chronically inflamed, and even neurodegenerative diseases like dementia, as evidence suggests these particles can cross the blood-brain barrier. For decades, this threat was largely invisible. We could see the smog, but we couldn't track the pollutants with precision. Now, we have eyes in the sky. In 2023, NASA launched TEMPO, a revolutionary instrument that monitors North America from geostationary orbit. For the first time, it provides hourly data on pollutants like nitrogen dioxide and ozone at the neighborhood scale. We can now watch pollution evolve throughout the day, identifying hotspots and understanding how it moves. It joins a global fleet, including the European Space Agency's Sentinel-5P satellite, which maps a suite of pollutants across the entire planet every single day. This data isn't just for scientists, it's a tool for accountability. It allows us to see what policies work and where we are failing. And some policies are working. Look at China. Since launching its Clean Air Action Plan in 2013, it has achieved a staggering reduction in sulfur dioxide and fine particulate matter, leading to measurable gains in life expectancy for its citizens. In London, the implementation of the ultra-low emission zone, or ULEZ, has led to significant drops in nitrogen dioxide levels, with studies showing it has already resulted in improved lung development in children. These successes prove that when technology, policy, and public will align, we can clean our air. So, what does the future hold? How do we accelerate this progress and protect ourselves today? The solutions exist on every scale, from the futuristic to the profoundly practical. In dense urban canyons where planting trees is difficult, scientists are deploying liquid trees, algae photobioreactors that can absorb carbon dioxide and particulate matter with incredible efficiency, hundreds of times more effective than a single tree. And for our indoor air, researchers are engineering common houseplants with synthetic biology, giving them the ability to metabolize harmful volatile organic compounds, chemicals like formaldehyde and benzene that are common in our homes and offices. Then there are the more radical ideas, often called a last resort. Solar geoengineering, like stratospheric aerosol injection, proposes releasing reflective particles high in the atmosphere to cool the planet. While it could potentially offset some warming, the risks are immense and poorly understood, from disrupting global weather patterns to the moral hazard of delaying real emissions cuts. It is not a substitute for addressing the root cause. Okay, shock over. Let's fix what we can today. The power to protect ourselves and push for change is in our hands. First, check your air. Use a free air quality index or AQI app and set alerts for your location. If the AQI is over 100, it's a good idea to dial back strenuous outdoor workouts. Over 150? Keep outdoor time short or move your exercise indoors. Knowledge is your first line of defense. Second, upgrade your breathing zone. A high-efficiency particulate air, or HEPA purifier, correctly sized for your room, can slice indoor PM 2.5 levels by over 90%. If you're on a budget, a DIY box fan filter built with a high MERV filter is a solid stopgap. Just be sure to build it safely and never leave it running unattended. Third, ventilate smart. Always use an exhaust hood when cooking and make sure it actually vents outside, rather than just recirculating. On days when the outdoor air is clean, open your windows to flush out indoor pollutants. When the AQI is high, keep them closed and seal any gaps to keep bad air out. Fourth, commute cleaner. If you can, carpool or take public transit. When you walk or cycle, even moving 1 block away from a busy road can dramatically cut your exposure to traffic fumes. And on bad air days, wear a high filtration mask. A certified N95 or FFP2 respirator will capture the tiny particles. A simple cloth mask, unfortunately, won't. These personal actions are crucial, but they are shields, not solutions. The real solution lies in collective action. We must push for the big levers, a rapid transition to clean energy, stricter emission standards for industry, and the electrification of everything, our buses, our buildings, our industry. We need to vote for policies that phase out dirty combustion and redesign our cities with human health in mind, with more green spaces and tree-lined streets that cool and filter the air. Air pollution isn't inevitable. It's a design problem, a consequence of a century of choices, and that means we can make new choices. We can redesign our energy, our transport, and our cities. Together, starting with the small vital steps you take today, and scaling up to the global transformations we must demand, we can redesign the very air we breathe. We can restore our invisible ocean,